Hello, glad to have you join this session in which I'm going to discuss data exploration and tidying with Tableau. Specifically, we're going to review how to sort your data, clean your data, conduct joins, and look at cross-database joins and blends. Let's get started. The first thing we're going to look at here is how to sort your data using Tableau. So sorting as such is pretty intuitive. It means ordering your data in ascending or descending order. What we're going to do here is examine how you can conduct a basic sort and then a nested sort, and the various places from where you can request Tableau to sort. So to do this, we're going to use the sample superstore dataset. So now I'm going to head over to Tableau to open that dataset up. The sample superstore dataset can be found in the blue ribbon on the bottom left-hand corner of your screen. Okay, so I'm going to click on that now to open the dataset up. And on clicking on that, it pulls up the data. And now I am in the worksheet view of Tableau. I like viewing my data organized by folder. So I'm going to change the settings here to group by folder. There we have it now. The first thing we're going to do here is we're going to sort our data by number of orders. In order to examine the effects or view the effects of sorting, I'm going to set up a bar chart first. A bar chart containing number of orders by region. The variable region is a geographical variable present under location. I'm going to drag region over to rows. And then I'm going to drag orders count over to columns. At this point, I've got a bar chart that contains information about the number of orders placed by region. If you hover over, you'll see the number of orders for every region. From the bars itself, you can notice that West has the most orders and South has the least. When you're presenting your data to somebody, it usually is desirable to present that in ascending or descending order, unless the order of the data is meaningful. In this case, the order of the regions is merely alphabetical, and it may not add as much value to your audience. So what we're going to do here is we're going to sort this data in descending order of number of orders. There are a couple of ways of going about this. One of them is we can sort from the option in the region pill. Also, we can find a small icon that'll show up when you hover over the top of the axis, or we can go to one of the menus. Okay, so let me go through every one of these options one by one. First things first, here's when you hover over the bar chart, you can notice the small icon appearing. If you click on this icon, it'll sort the bars in ascending or descending order, like this. When you click the first time, the bars are ordered in descending order. If you click again, they'll go to its ascending order. If you click yet again, they'll go back to their default order. It's like a reset. Now, if I go to the very top up here, you can see the icon that says sort descending. Now, if I click on this icon, it'll do just that, sort in descending order. If you click again, nothing happens. Click the other icon, it's going to sort in ascending order. To undo this, of course, you can hit the back button twice. Finally, you can sort by using the region pill in the rows shelf. By clicking on the caret right by the region pill, I can select the sort option. In the sort option, you can select sort by data source order or one of the many other options. One of them is field. If I click on field, it's going to show me an option of how to order my data. I'm going to select sort order descending. Ensure the field name selected is orders. That's selected automatically for me. And aggregation count. Tableau made these default choices based on recognizing the fact that the pill in the column shelf is count orders. Now, let's try and make this ascending order. There you go. Okay. So you get the idea by now of how you can sort your data in descending or ascending order by either the pill or on one of the markers on the axis. I'm going to go on now and construct another bar chart. This time, I'm going to sort sales by region and subcategory. So we're going to have 2 dimensions to sort the data, or rather, we're going to sort the data across 2 different dimensions. Let's call this sheet something first. So let's say region, let's say simple sort, right? And then next one, I'll call this a, let me just, you know what I'll do? I'll copy the sheet over. So I'm not duplicating my work. I'll say duplicate data or duplicate the sheet. Now the new sheet looks like this. I'm going to call this it's sort, what are we doing? Sorting region and subcategory. The last one was sorting just region. So here we have 2 dimensions now to use. Naturally, I've got to bring the second dimension in. Let me look for subcategory here. It is under product. I'll drag subcategory over to the rows shelf. Okay. Now it looks really messy right now because there are a number of subcategories within any given region. As you can see right now, data is sorted by region. That sort is intact. West is on top. However, the subcategory is not sorted yet. You can tell from looking at the bars, they're just all over the place. It may actually be easier to look at this in a vertical bar chart. So I'm going to rotate the axes here. So you can see another view of this thing. Okay, you can tell like they're not in any order right now. So what I'm going to do next is I'm going to go to the subcategory pill, and then I can look for the sort option here. I'm in the subcategory pill, and I'm going to look for sort. And here I have an option of sorting by data source, the default, or I can sort by field. I'm going to select field, and then sort the data. Well, it's already doing it for me in descending order by orders and count of orders rather. And there we have it, okay? The data is sorted nicely now, first by region, and then by subcategory. Now, a couple of things you'll notice here. I may have misspoken. The data is sorted by region, and the data is sorted by subcategory. These sorts are independent. Right? So if you look carefully here, we're sorting here by different regions, west appearing first, second, east, then central, then south. And then we have another set of bars of the subcategories, and they're appearing again in order. Now, the order is at a global level. So binders had the most sales, most number of orders, and therefore binders is always appearing first, and then paper second, and so on. This orientation can be a little hard to see because, again, the labels are written sideways. So what I'm going to do is I'm going to rotate the axes one more time so we can go back to looking at the horizontal bar chart. There we are. Now, you can see out here quite clearly that binders appears first in every single region. And that may be, fair. In our view right now, you can notice, if you look very carefully, you'll notice that number 2 is indeed paper in both west as well as east. Furnishings is 3, and so on. Not rocket science. 1, excuse me. And phones comes in 4, and then 5, 6. So you get the idea by now. Okay, phones is 4, storage is 5, and so on and so forth. So as you go down this list, a lot of them make sense until you get to, art. And then you look at accessories. You look at art and accessories carefully, you'll notice that accessories is a little bit more than art. Similarly, look at labels and tables. Again, tables is a bit more than labels, yet it's ranked below labels. It's more jarring for envelopes and bookcases, right? Okay, so the question is, why is this happening? It's happening because subcategory is being sorted at a global level. Binders have the most sales overall across all regions. Paper is number 2 overall across all regions, and so on. Now, what we usually want to do is, what we are usually interested in doing is not really a sort like that. We're usually interested in doing a slightly different kind of sort. Let me copy the sheet over and I'll tell you what I'm talking about here. So what we're normally interested in doing is something called a nested sort. That's the more natural thing that people are looking to do, even though they might not call it a nested sort. So in this view, you can see the same sheet again showing up, calling it nested sort. Let's see what's different about it. What's different is the fact that we're going to do a sort by region first, and then we'll sort all these different subcategories within the region. Let's see how this goes. Okay. Let me get myself some more screen space here first. Expand that. Okay, sorry. Okay, so let me click out of here and give me some more space here. Okay, there we are. All right, so now what we're going to do is we're going to sort by subcategory within region. So the sort is first by region. We'll leave that untouched. I'll go to subcategory, and I'm going to select here sort again. This time, I'll select nested sort. As soon as I click on this, you'll see some change. So let me just move the window over here. Click on nested. And you'll notice some rows got swapped, some bars got swapped. So now you'll notice here that the order of west is not the same as the order of east, because we're doing a sort within the given region. So we sort first by region overall, and then we sort within the region west. As a result, you'll see here binders appearing first, paper second, so on, right? 4, 5, 6, 7, 8. Okay, I'll stop writing now. And you go down here, binders 1, 2, 3, 4, 5, 6, 7. Okay, and 9 for appliances. If you look at art is number 6 in East, but in West it's number 7. If you go back to the previous sort, you'll notice that the subcategories is the same ordering regardless of what region you looked at. And that's because it was a non-nested sort. Okay. Usually what we're looking for is a nested sort. And so generally speaking, Tableau will by default try to do a nested sort for you. But if it doesn't, you may want to go in and set that up by as follows here, as we've done here. Okay, so that's a little bit about sorting our data and a nested sort. Let's move along and look at how to clean our data. Now, if data has to be cleaned, you might think, well, data must be dirty. That's why it has to be cleaned. We don't mean filthy, and we don't mean we're not making a moral judgment about data either. We're merely saying the structure of the data may make it difficult to work with. Right? It may not be amenable to analysis because of the format and structure of the data. So we're going to clean the data to make sure that it can be more easily used for analysis. So this can be a pretty painful task in most scenarios. Tableau makes this process really easy by automatically, almost like some sort of auto program that'll automatically do a cleanup for you. Think about it as a Roomba for your data, thanks to Tableau. Now, it's not available for all data formats, but it's available for a couple of different ones, including Excel, text, PDF, and Google Sheets. This will usually go in and look for tables, subtables, titles, footnotes, clean them up. There's white space, it'll take them out. So do some nice cleanups for you, make your data more usable. Before we can do that, let's go and take a look at what is meant by messy data. What's so messy about data, or this particular data set called messy crosstab, for instance? And why do we care? Like why do we care so much about cleaning our data? So I'm going to share with you now a sheet called messy crosstab, and I'll open that in Excel. Here's the file. So messy crosstab looks like this. It says here summary report of sales and profit by region over the last 4 years. And it's some data I just made up, right, from Superstore. And so in this data set, you can see that we have a lot of problematic issues with regard to analysis. Generally speaking, when you want to analyze data, you want it to be such that it begins in the top left-hand corner, right? So a classic thing about any good data set is it should always begin in the top left-hand corner, and every column should have a variable name, and the variable name should be in the first row or in the header column, header row. Things like this, merged fields, are a big no-no for clean data. So we might want to then remove this thing to clean this up, move the whole data out to the top left-hand corner, unmerge these merged fields, and scratch all this stuff out. Okay. So that's the kind of thing you'll do to make your data more usable and amenable for analysis. Let's see how this works in Tableau. So I'm going to close this data set, and and I'm going to share with you my Tableau screen. I'm going to go in and fetch that data set, and let me call this, well, you know what? Let's go in here, and I'll bring in that data set called messy crosstab. Here's data. Now, when it comes in Tableau, here's what it looks like. Still looking pretty messy. Okay. Look at all this stuff going on here. And Tableau knows that you can't have like a blank cell. It just violates, the integrity of your data if you've got these blank cells that have nothing in them. So you gotta mark it as missing if there's nothing in there. So Tableau plugs in a null value here, assigns variable names by default. That may not be very meaningful, but it just does those very, very quickly to the data. Now we know that we don't want this stuff. These columns don't have to be there, and we don't want this top row either. We want to just look at the data. We want these to be our variable names, so on. So all I'm going to do right now is go to the top left-hand corner and check this box for data interpreter. Let's see what that's going to do for us. So when I check that box, here's what happens. Amazing, huh? As soon as I do that, notice all the first few rows that were blank, the first few columns that were blank, all are gone. Our footnote is gone. All we are looking at right now is data. Now, it's not perfect because Tableau doesn't know everything about our data. For example, it doesn't realize that year of order date is actually a date format. It's marked that as a number. We can, of course, deal with it very quickly by modifying the format to say year. So I'm going to go here and say, I'm going to call this date. And there we have it. Now, you could go one step further. You could set the formats of profit and sales to dollars if you wish to. But the bottom line here is Tableau very quickly and easily clean this data for us, so that we can take the next step on working with this data. So that was one example of a really messy looking data set. Let's take a look at a few more examples. So we're going to take a look at here a data set called popestimates.csv. This is I pulled it a while ago from American Fact Finder. The US Census basically has this data set out there, so you can go and find it there. Now, there's a lot of issues with this data set. Let's pull that into, let me open this in Excel again. We'll take a look at it there before pulling it into, Tableau. So here's the data set. Again, there's a file called popestimates.xlsx and one called .csv, same file, and they have the same problems. But I have them in both formats if you want to open up either one of them. So There are a couple of issues going on here with this data. They may not be apparent by just looking at it, but they will become apparent once we bring this into Tableau. I'll highlight a few of them. One of them is that we have a row here for the United States, and and then there's different states in the country also listed below. Now that's a problem because data is at different levels of granularity. We want the grain of the data to be the same across rows. So if the data for 5 rows is on state, the 6th row should also be on state. You don't want a total row in, amongst, non-aggregated rows. That's just this is poor data hygiene if you have that going on. So let's go to Tableau now. I'm going to first close this file. And I'm going to do Tableau, and we'll pull this in Tableau next. We're in Tableau now. I'll open the Excel format. Again, it doesn't matter, Excel format or text format of pop estimates. Either one of them will give you the same messy looking data that looks like this. Now, as you look at this data set, a couple of things should pop up right away. You can pause this video and then take a look at the issues here one by one. Yeah, maybe you want to do that actually, and then kind of make a list and see if that map matches with what I'm going to go over here. So hit the pause button now if you'd like to. Okay, if you've identified the issues with this video, here's what I find problematic. First of all, this row shouldn't even be there. Second of all, this row here is for the United States. It shouldn't even be here. Okay. And then there are rows like District of Columbia. Well, that's not a state. That shouldn't be here either. In fact, if you look at the number of rows, there are 54 rows. Why are there 54 rows? Should be 50 because there are only 50 states in America. So let me do these cleanups manually because not everything happens automatically. So for example, if I check this box, it may not clean up everything. Let's see what it does though for us. I check the box and it has taken away the first row. So at least it's done that job for us, but there's more work to be done, which we're going to handle manually here. So click on the Add Filters option here to remove the United States from the list of states. Actually, let me do this first. Let me rename this to be state so I know when I'm looking at the variables that this is a state, or should be a state. And then I'll add a filter here to remove the United States from the list of states. Okay, so United States, I can type in here, United States, and then check that box off. Okay, now let's see what else. There's still 52 more values that are selected here. And I know not all of them are states. I know DC is not a state. Let me check that box too. And let's go down this list, see what else might be a value that shouldn't be here. Okay, Puerto Rico is not a state either. Okay, with those boxes checked, we're down to 50 states now. These are checked, so I'm going to say exclude, meaning basically exclude all the checked values here, and that leaves us with 50 states now. Okay, hit OK again. There we have it. We're down to 50 states. Our data is 50 rows. Job done. Okay, you may also, of course, want to change this to a geographical role, identifying those as being states in the United States of America. Okay, so this is something you can do again really quickly here and easily, quick cleanup of your data as we have done here. All right, moving along, I'm going to now go back to our slides and let's see what else we can do here. Okay, so we have some data here again on Tesla from Google Trends. Now, Google Trends is a really cool, set of data. It kind of shares information about who is searching for what. So what Google will do for us is share with us this wonderful data set, and I'll pull that up here, which includes keyword searches indexed by month. So for instance, in 2004, January, Tesla was hardly searched. So you can go to Google Trends and you can, tell it to do a search there. So that's what I've done here. I've done a search for all categories of, Tesla car searches from, Jan 2004 onwards. You can see the numbers here listed here. Okay, so a couple of issues might stand out here for you. One of them is that if you look through this data, you have right on top here some white space and a title for the data. That shouldn't be there in a clean data set. So what we want to do is we're going to take those out. And we also want to codify this column as being a date column. So we'll do this by bringing the data into Tableau. So again, I'm going to close this in from Excel. Head over to Tableau. Click on the Start page or Home page. And I'll bring in the Google Trends data. Here we are. Here's the Google Trends data. Again, you can see that there's this problematic, first two rows of data. And we want those to go away. So let's make those go away. We'll check the box for Data Interpreter to see what it'll do for us. Bingo, it's done it, right? As simple as that. All we have to do now is rename this to, I guess, search index, which reflects the number of searches for the car Tesla. And we'll transform the month column to a date type. And we're done. We're set here. And of course, once this is done, you can, of course, have fun here. You can go in and make your little sheet if you'd like to. Quick and dirty, for example, you can do a quick and dirty, search trend kind of Google, something like this. That's really dirty, actually. Let me swap the rows and columns. It's really messy right now. And you can see kind of searches of the car Tesla over the years, how it peaked in 2021, and people aren't searching for it as much now as they were back then. Okay, so that was a fun little graph, right? Okay, we'll make a lot more of those soon enough, but for now, let's move along to take a look at one more messy looking data set. This is the Gender Inequality Index data set. And again, this has got a whole bunch of issues within it, probably far more serious than the one we've seen so far. You can find this data on the UN data website. So I'll spend some time going over the different issues in this data set one by one. Okay, so first things first, I'll open up that data set in Excel. Here is the data on gender inequality coming up in Excel. So pretty problematic if you look at it. Again, if you want to pause the video, take a look at the data set, you can do that, identify all the issues you see here, and then I'm going to go over the issues one by one. So, all right, so instead of spending time on Excel, let's bring this in Tableau and then clean up from there. So I'll close this out again, head over to Tableau, and pull the data into Tableau, and then we'll clean it up. Okay, so let me click on, it was an Excel file, I believe. So here we are. Gender inequality is the name of the file, index is the name of the file. Now, it has two tables, table 5 and references. We don't want the references, so I'll drag the table 5 in here, see what it contains. This is a database that basically compares different countries across the world based on the level of gender inequality and provides information about a couple of other variables. So let me shrink this view. And as usual, the first thing I'm going to do here is run the data interpreter to see what it will do for us automatically. We have it. It has cleaned up a lot of data for us automatically, which is kind of nice. It's cleaned it up, but it's still very messy. So I don't know what F1 is anymore. And I don't know what this is. It's something. And then, okay, there's a null column here. Okay, so it might make sense for me to have the other Excel file open so I can look at what these things are, because I'm going to have to go in here manually and do a lot of work to fix those things. that, so here is the Excel sheet again. The first column is HDI rank. That's been renamed. The second column is country. The third column is the value of gender inequality index. And the fifth one is rank. Okay, with those in mind, let me head back to Tableau and do some renaming to make this more clear. So the first one is our HDI rank, Human Development Index rank. And the second one is simply a country. Let's call it that. And it's a geographical entity, so I'm going to call that geographical role, country. The next one is our gender inequality index. So let me name this to be gender inequality index. And the next column is our gender inequality rank. Okay. Looking at the Excel sheet now, I'm toggling windows. If you don't know why, how I can read that, it's because I'm looking at the other window now, where it appears like the next column is the maternal mortality ratio. Okay, so meaning that to maternal mortality ratio. And then the one after that is just a blank column because we had some blank columns there. I'm just going to hide that column then because it's not helpful to us. Okay. The column after that is the adolescent birth rate. So let me rename that to adolescent birth rate. And then we'll go on here to, it says share of seats in parliament. Okay. Held by women, I believe. Okay. So percent seats in parliament by women. I guess for us that might mean our Congress. Okay, and going furthermore, I'm going to go and select, well, and it's another, again, I'm going to just hide this field. It's not any value at all. It's nothing there. And the one after that is saying it's the population. So this is the population, it's secondary. Okay, say, it should be percent female with secondary education. You copy that. And we'll go on here and do the same thing here for the next column, which is blank. So I'm going to hide that one again. The next one over is the same information, but for men, the percentage male. And then the next column is again a blank, so I'll hide that as well. And then the one after that is the labor force participation rate, so percentage female labor force. And then we have the last one, we copy this name again to make my job easier. And then rename this last column to be the corresponding variable for males. Okay, right. So after all that work, we're finally pretty much done here. We have this whole thing done, I believe. We have a nice table here that we can use to construct. Oh, wait a sec. What's this thing in the middle? Whew. Maybe you're not quite done, huh? There's this row here called high human development. And they've got, I guess, rows in the middle. Let's just look at all the data here. So 100. So we can scroll through all the data, see if there's any other problems here. Medium human development. Okay, so this is not quite clean yet. We have these rows that, I guess, segment the data into high, medium, and low human development, which we want gone. And there's some countries in the bottom, some footnotes, I believe. We don't want those either. Now, the one way to identify them is by HDI rank of null. So what I'm going to do here is I'm going to go and say here, add a filter for HDI rank. And if it is null, now null is under special. So if you see a null value, just remove it. Or I can say, just give me all non-null values. Okay, so give me all non-null values, and that's pretty much going to be everything that's not a null value. So here we are. You now have 191 rows of data. We have removed a lot of the objectionable, problematic rows. And here is our final data set, cleaned and ready to go. Okay, so that was a lot of work cleaning that one up. It was much more work than the ones we've seen before. Now, so sometimes data interpreter works, but it doesn't do everything for you, but it sure does lighten up the burden of cleaning up the data for us. Now, the data interpreter has some constraints. It is only available if the data is in the format Tableau can make sense of. If the data set is not too large, it's below 2,000 columns and no more than 3,000 rows. And 150 columns. So, one of those, you want to make sure that it's within, range and the data source is supported. Okay. Now, if, for example, Tableau data interpreter doesn't do it for you, there's always Tableau Prep available. And of course, there's many, many other software where you can clean your data before bringing it into Tableau. All right. Now let's move on to what is tidy data. Now, this might be a little misleading because, tidy makes it seem like, well, we're going to fix data up, tidy it because it is untidy. Well, not really, but the name is stuck thanks to Hadley Wickham, one of the gurus in the world of R programming, the author of many R packages, including tidyr and tidyverse and so on. So he basically coined this phrase in a paper he published about many years ago, where he basically said, there's wide data and there's tall data. And so he referred at the time to tall data as being tidy. Since then, we agree that data can be usable even if it's wide, that is not in a tidy form. But yeah, it is true that in most cases, you want the data to be tidy. Let's see what that means by way of this small example. So here we have 3 countries listed: USA, China, and Japan. You can see out here, we have 2 years, 1960 and 2017 as the years listed. Now, what if we could take these 2 columns here and move them to the rows? We could then write 1960 a couple of times out here. Yeah, like this. And then 2017 a couple of times below that. And then we'll move, and we'll call this a year column, right? So let me just abbreviate that YR. And then we have another column, we'll call this the column for GDP, or is that population? I believe that's GDP. Okay, so yeah, that's GDP. So we'll have GDP column now, and all these numbers, you see these 6 numbers, will not go over under GDP. We'll also repeat the countries 3 more times below. And when you finish all that, you're going to get the tall data column format, right? Okay, so generally speaking, when your data is in tall format, it makes it more amenable to a wide range of analyses, and many software just want your data to be in a tall format, including Tableau. Others like R, for example, many R packages, many Python packages all want your data to be in a tall format. So really good reason then to make sure your data is in a tall format before going ahead to analyze it. Let's take a look at some more about this. We'll look at some data sets out here. Let's begin with the United Crime Reporting data. Well, it was published in the past in a wide format. Fortunately, since then, they moved to a tall format, which is good. I'm glad they listened to Hadley, and they have changed their format. So here is the original data I'll share with you. This is data of the crimes data that I alluded to. Okay. Excuse me, it's taking me some time to find this data set. Okay, so here is coming up. Here is one of the crimes data sets, and sorry. All right, so here's one of the crimes data sets you can find. There's a couple of them. Right. Here's one of the data sets you can find out here. You'll see out here the data is actually this data set not in a bad format, because you have here the year and the state listed here nicely. So the good part is that the year is in a kind of a tall format. But if you're going to compare different levels of crime, here are the different crime levels. You may want to then put these all in one column. And that's what we're going to do here, okay? So we'll kind of work with this data set here, bring this into Tableau, and then we'll kind of make this into a taller format. You'll see how this changes the format in just a second. I'm going over to Tableau now. I'll bring this data set into Tableau. This is the estimated crimes data. And here's the data set. Okay, so it's not terrible, but it can be better. So first things first, I'm gonna check the data interpreter box here, let it do some basic cleanup for me automatically. And by the way, you may have noticed that when you do that, it gives you a small link here so you can review the results. Here's where Tableau will share with you all the cleanups it did automatically. So if you want to review that, you can do that. Okay, so going forward now, let me go in here and see what I can do. Let me do first things first. Let's first, set the year to date. And next, I'm going to do some basic cleanups here to only include states that are actually states. So add a filter, which will help me remove the states that are not a state. Like null is not a state, and District of Columbia isn't a state either. And what we have here, and that's it, I think. That's good enough. Hit OK. We're down to 50 states now, which is great. Oops, sorry. I ended up making a small mistake up here, so let me go back and fix that. So what I did was I should have also checked the box exclude, so I don't get the null in DC. Let me do that now. Okay. When I did that, and just to verify, if I do that, it'll drop the two entities I don't want and bring us down to this table here. Now it's common, usually you want all these numbers here to be in a tall format. Now I have two options here. I can either say I'm going to include the population and the crimes both in a tall format, or I'm going to only include the crimes in a tall format. Let me only include the crimes in a tall format. So there's a caveats column in the end. That's just, I don't know what that is, so I'll just hide that. It's not useful. Okay, make that go away. Okay, and next I'll just highlight all these columns from left to right, beginning with violent crime. So to select multiple consecutive columns, you hold the Shift key down in a Windows machine and a Mac as well, actually. And then you select the last column. And when you do that, all the columns are selected. Now, to make this a tall data format in Tableau, what you do is you pivot the data. So click on the caret right by motor vehicle theft to then select pivot. This will then make the data tall instead of wide. Here it is. So that happened kind of fast, but if you paid attention, close attention, you may have noticed the data has fewer columns and many more rows. There's 20,000 rows and 6 fields or columns. Let's see what it was before. So I'm gonna hit the back button now, and see now before it had 14 fields and 2,000 rows, and now let's hit the do a repeat button, a redo button. Here we are. Okay, let's give these names. So these are crimes, and these are counts, I think. So we have the number of crimes, or you can just be like more nerdy and say this is the N, right? The number. Okay. And so you can see here crimes. And now if you want to do something like you want to compare to a crime rate, you could do that by doing the N divided by population. You can do that in math to get the crime rates for various states over time. Okay. That was one example of a messy, wide data format that we may want to make into a tall format. Now, here's another one. This one is interesting because, when I pull this data, I noticed that while the FBI is reporting data in a tall format now, New York City at the time of this recording right now is not doing that. So let's take a look at New York City's data that I'm talking about here. So here's the New York City data coming up. Okay. So the New York City data looks like this. Here we have data on, different, these are population estimates over time for the 5 boroughs of New York City. They also report data for overall New York City population. Now, going back to what I spoke earlier, generally speaking, you want to make sure all the rows have the same level of grain. That is, if each row refers to a borough of New York, then it should have just that, boroughs. It can't have the overall total or average for all the rows of data. So first row must go. Furthermore, the years should be pivoted or rotated or made tall so that they're in one single column. Let's see how we do that in Tableau. I'm going to close this window. And let me go over to Tableau now and pull this data in there. Okay, so here we are. The New York City data. First things first, check the box for data interpreter. It didn't do anything. I don't think it did, at least. Well, I'll leave it check anyway. It usually does a good job. Let me uncheck, actually, see if it did anything. It didn't do anything, so let me not bother with the data interpreter this time around, because it's doing nothing for me. So let me first things first remove New York City from this list of boroughs. So borough, and then we'll remove New York City total, because we only want data. Oops, let's go back, edit that, and exclude the NYC total. And now we're looking at our data for the 5 boroughs. The first column is redundant because it is the same information. I'll hide that column. Okay, now what I'm going to do is I'm going to go in and basically select all the, there's 2 things I could do. The borough share of New York, if that's redundant, I can just hide these columns. If I don't want to know the share, let's say I don't want to know the percentages, I'll hide each one of them. All I want to know is the actual population, let's say. If that's the case, I can hide the share numbers. So make it simpler, easier to look at. Okay. Let's hide all these one by one. Okay, so all the share columns are now hidden. All we have is a raw population, current and projected, for the different boroughs of New York City. So next thing to do is to select all the columns. And by the way, if you want to select individual columns that are not consecutive, in a Mac, you press down on Command. On a Windows machine, you press down on Control, and then do multi-selections like this. But if they're consecutive, you could have just clicked on the first, and then with Shift press down, click on the last one to select consecutive columns. Okay. With this done, I'm going to now pivot the data, and bingo, we're done. Okay, rename this to year, and then this to population. And let's click on ABC to make that a date. And the borough is really a geographical role as a county. Well, they are counties as far as America is concerned. We call them boroughs, but they're really counties. Okay, right, okay, great. So Population is a number. And let's just have some fun with this data before we go on. I like having a little bit of fun every now and then. So let's take a look at the picture, see what it looks like, right? So let's just say NYC population, right? And maybe you want to look at, now all this hard work is done, we'll see why we're doing all this work. Well, one reason is you want to make a line graph maybe of all the different years of data, and then you want to maybe look at drawing comparison by borough to see, well, how is it varying by different boroughs? And here we are. So you get this kind of colorful graph, maybe a little too colorful actually. So I'm going to make this just a label. I'm going to make the colors gray. I like more muted colors. You can kind of see out here that you can see the growth of population, how in the, I guess Brooklyn hit a low in 1980, right? Brooklyn's the most populated borough, it seems like. And also that it's kind of hit this low in 1980. Same for actually all the boroughs. Yeah. Like people left Manhattan in 1980, right? Look at that. Except Staten Island, that's just been flat and constantly going up. But really, there's been a lot of migration to Brooklyn, seems like, over the last couple of years. Or they're projecting that, sorry, that's a projection. They're projecting flat level of growth for Manhattan, and Brooklyn really growing fast, okay? If you're a real estate investor, right, you can use this data. Okay, so that was the fun part. Okay, we'll get back to going back to our slide now. Let's go on and see what else we can do with our data. So one thing you sometimes want to do is you want to combine a lot of data sets into one. So for whatever reason, your data may come in many different files, right? So you want to combine them. And sometimes what happens is your data is basically the same columns, the same structure. You simply want to stack them one on top of the other. Okay. If that's the case, you would do a union to combine them. We'll look at a couple of different data set examples out here, and I'll go through a fairly fast clip at doing this because it's super simple to do. Let's do something fun. Okay, so let's Tesla Union. We'll do this one here. So you can either use a Tesla CSV files or Tesla Union to do this. We'll do it with each one of them. Let's take a look at some of the Tesla files first, the raw files, before going into unioning the files. So here's the, so here are two of the Tesla files coming up. Here's the data for, year 2022. We have data on, what is this? The date, the year, and Tesla's OHLC data, their open, high, low, and close for the Tesla stock. Okay, for the year 2022. Okay, this is real data, by the way, pulled from Yahoo Finance using the QuantMod package from R. Okay, so that's 2022 data. Let's take a look at 2015 data. Again, same numbers, same structure rather, I'm sorry, not same numbers at all, but the same structure of the data. Okay, so with that in mind, what we're gonna do now is we're gonna head over to Tableau, and we are going to bring this data in. I'll click on text file and look for these files. So year 2015 is the file containing the Tesla data. Excuse me. Okay, so here we are. 2015 is in. And so one thing you'll notice with Tableau is that whenever you load a CSV file, it'll show you all the other CSV files in that folder. It almost sees that as being part of one database. Even though it's not really a database structure, it treats text files in the same folder as being part of a single database. In fact, we'll see later on, if you're joining two tables and they're not in the same folder, Tableau will treat that as a cross-database join. Okay, so that's your spoiler alert, huh? Okay, so let's go in here and take a look at these different files that we can view here. So they're 2015, 16, 17. Okay, so I will first things first shrink this a little bit here. Now, there's like a repetition here. The column 1 and 2 are the same. Okay, not going to worry about that now. We'll worry about it later. We want to stack the next set of columns below this one. So what I can do here is, I can do this in a couple of different ways. One is you may be tempted to just drag and drop on top of 2015. You can do that. just be cautious not to do this. You know where that rope-like thing is connecting to 2016 data? Don't let that happen because that'll create a relationship. You don't want to do that. We want to stack the data, so you want to put it right on top of 2015, and now you're doing a union, as the small annotation indicates. Okay, so when I did that, what happened? Okay. It doesn't look like it did what we wanted to do, did it? Okay. So that was didn't have the intended effect. Maybe I was hovering over a little too much. Let me try this one more time. So I'll drag 2015 over here and then drag 2016 right on top of that and see if that does the union for us or not. Okay. So that did not do it either. It's simply created another file. It's replaced 2015, 2016. So that's not what I want to do. So I failed twice with this. I believe so, right? Let me try and remove this one more time. So I'll go to plan B. What I'll do is I'll do another way of doing a union, which is selecting all these files together and then dragging and dropping them onto in here. And you'll notice now that worked. I know that for a fact because in a given year, you don't have 2014 days. The data is daily stock trading, daily data for when the stock market is open. And there are about 260 days when the market, I think 260 or so days when we have the financial markets are open. So that means we should have, this is a couple of years of data. So you should have 260 times the number of years of data showing up here. Okay, so we can tell here we have in fact created a union. Let's verify that. You look at the last column, it shows you the table name. It shows you the source of the data. If you keep scrolling, you'll end up stopping at 100. To get all the data, it'll make this number really big, like I'll say, like a random huge number, right? I know there are only 2,000 rows, but I'll just say 5,000 or something. And that's going to correct this to 2014. And we can then scroll down below, and you can see as you scroll down below, you get to years after 2015 all the way to 2022. Okay, so let me just do some cleanups here, and then, well, I'll save cleanups for a little later, right? Because I want to do a few more things here before we get there. So this was one way to do your union. Let's explore a second way to do a union. I'll remove this now. And a second way to do this is you drag one table in here, and usually you should be able to drag in more tables on top, and it should work. Let me try that one more time. Okay, this time I'll do it faster, and it didn't work again. That's a little bummed that it's not working so well for me. Okay, so I won't try that again. Okay, instead I'll show you another way to do the same thing. So we'll kind of remove this one also and say, okay. So drag 2015 over here as before. This time I'll go to the card for 2015 and look for the convert to union option. Here you have the option to either, you can drag in different tables. So I can drag in all the tables here and say, oh, there you go, they're all in. If I say apply, it'll union all 8 tables into one. Let's verify that works first. Okay. There you go. We now have 2014 rows again. Let me show you yet another way before we move on. Move this, drag any one table in, 2015. This time we will use a wildcard. Convert to union like before. But this time I'll click on the wildcard option. And I'm going to say here, include files that contain, well, what's common across these names. They all say year something. So it's a year. And if you just simply say year, it should work, but it doesn't. Tableau kind of functions a bit like, old-fashioned DOS programs, whatever that is. So you do year star dot star. And when you do that, star as a wildcard means that's a bunch of other characters, could be none or more than none characters. So it would include just year dot and even more than that. So year star dot star, or even year star, I believe will do the job for us. Say apply now, and it knows now to include all the files in this particular folder that contain the keyword year in them. I know there are no other files that contain year in them, so I can now say, okay. And that is going to create another way to create a join for a union for us. We now create a union of 2014 rows. Okay, well, let's have some fun now again. Okay, so we've done this union thing. Let's examine how this data looks like. We'll do some quick cleanups out here and then head to having some fun with this data. So I'll hide this column, it's a repetitive column. Year, okay, that's good to have. What I'm going to also do here is there's this column called Data Union Year 2015. This column is a very useful column. Believe it or not, it tells us the source of data. Now, if you look carefully, we already have the year. We know that. But what if you didn't? If you didn't, you could parse the year from this field. You could chop this up and say, give me this element. You could do this by splitting the column, right? Split the column, you can say split it by, I don't know, period or something like that. Say, chop it up into pieces and it will extract this, piece for me. So I can go here and say either custom split, which will allow me to specify how to split it up, based on a period, underscore, so on. Like this, I could say custom split. The separator could be a dot, or it could be a underscore, right? And split up the, let's say all columns, okay? And bingo, you get this picture here. Nothing really happened there, right? That wasn't very useful, okay? Let me undo that then and try this one more time with custom split. The custom split again, I'm gonna say here, use separator of period, and then give me the first column. So basically chop it up on the .csv. So give me everything before the dot. And so it's going to give me another column here. Looks like this. Notice that the CSV is gone now because it said dot is a delimiter. And next I'm going to go and split again. This time I'll say custom split again, but this time custom split using underscore. And I'm going to say if you chop using underscore, you'll get two columns. Give me the second column from the underscore delimiter. The second column, and okay, and bingo, we have now, nothing. Okay, I should have said third column, right? Okay, so because there's two underscores here. There's an underscore here, underscore here also. Third column then. Okay, let me fix that now. A couple of wrong turns, and we'll eventually get there. So underscore and third column, split off, yeah, last column actually, last one column, there you go. So last one column will do it for me, okay, and now we have a column just called year. I can now hide these columns I don't need anymore. Remember, hiding is not deleting, it's simply just not making them invisible. And you can call this, year ago, something else, or source, let's say source year, not to confuse it with the other year column here. Okay, and now I can go and have some fun. Let's have some fun here. So Tesla stock, let's say Tesla stock in a new sheet. And now let's look at Tesla's closing price. We'll examine this over time by putting date on columns. And now we can view the stock, how it's changed over time. You can break it down by day, like this. I'm going to show you all the wild changes on a daily basis from 2015 all the way to now, how the stock has been kind of went up wildly. COVID didn't help it go up as much as many other stocks did, but then has kind of died down. In 2022 was like gangbusters and then fell off a cliff again. Okay. So interesting little story of Tesla there with this data of ours. Okay, so you know how to union our data. You can do this with an Excel file, CSV file, so on. Okay. I'm going to now move into looking at joins. Now, if you have data in different tables, like they are organized in relational databases, you may want to join them together. Now, a join is required whenever you've got relational data. Relational data means the data is related. The relations help manage the data well, reduces redundancy, helps with maintaining integrity of your data in general. minimize duplication, help with security and privacy of your data. Lots of benefits of having relational database systems. They're very widely used. Most databases are relational in nature. So we're going to examine here how you can take two relations and join them together. The way you connect them or join them together is by something called a key. The way it's done is typically identify one variable that is called unique identifier in one data set, also known as primary key. We link that to the same field in another table called the foreign key. And that's how you connect them together. Depending on how the connection happens, you could end up with different kinds of joins. Specifically, when you connect two tables, you may decide to only keep rows that are common across both tables. That will be an inner join. If you decide to keep all the rows in the left table, but only common tables in the right table, common rows from the right table, you'd have a left outer join. If you decide to keep all the rows from the right table, but only common rows from the left table, you have a right outer join. If you decide to keep all rows across both tables, regardless of whether they're unique or not, whether they're common or not, you have then a full outer join. So full outer join will give you a very large table, possibly with a lot of missing values, right? While inner join will give you minimal missing values, but fewer rows to work with. Okay, so depending on your needs, you may want to look at different kinds of joins then. Now, Tableau in 2020 introduced something called a relationship. Relationships are not the same thing as joins. Relationships create connections or linkages between tables, but they don't merge them into a single table. They literally keep the two tables almost in their own state. While with a join, we take the two tables and we connect them together. We make another table altogether. So relationships are more flexible. Think about what happens if the underlying data changes in a relationship. Well, you'll see the change reflected in your data that's been related. However, with a join, that's not the case. In my opinion, a join would be less demanding on the computer system, will have fewer performance issues with it. Moreover, relationship is something that's specific to the Tableau environment. Joins is what everybody else uses everywhere else in the world. For every other platform, they use joins. So I am a big advocate of using joins over relationships. That being said, oftentimes the results are very similar regardless of whether you use a relationship or a join. Okay, so with that backdrop, let's take a look at an example. This is an example of a bookshop data set. Now, in this data set, you have a number of smaller tables. Every table has to contain something uniquely identifying every row of the data, called a primary key. This is typically labeled as an ID variable. For instance, the book has a book ID. The rating is a review ID. And a reviewer ID as well. Interesting. And a book ID as well. So there's many IDs, right? Now, the one ID that uniquely identifies it is called a primary key. Now, in order to connect the book table to any other table, I've got to find a common field, a common variable. Let's say I want to connect the book table to the ratings table. I've got to find a field that's common across both tables. In this case, it's the book ID. So what I'm going to do to get started here is we'll connect the book table to the ratings table using the bookshop dataset. So first things first, let me go and bring in that bookshop dataset into Tableau. The bookshop dataset we're going to use is in a file called bookshop, and that's an Excel file. So here's the bookshop dataset. It's called bookshop.xlsx. And basically, if you think about it, this dataset is essentially just an Excel file with different tabs. Rather than using an actual SQL Server type database, we're going to use an Excel sheet and pretend that it's, a database with different tables represented as different tabs in the workbook. So here are the different tabs I was alluding to earlier. One of them is the book table. When I pull the book table in, we get the following. So we have here 3 fields and 58 rows of data. And our unique identifier is book ID. Okay. We want to connect this to a ratings table. Let's take a look at that table first. So I'll take this off. The ratings table looks like this. Here again, we have a couple of columns. The one common column across the 2 tables is the book ID. We're going to use that for joining. Now, take that away. Let's begin with the book table. And now, notice if I were to try to drag ratings over to in here, Tableau is trying to build a relationship. And I told you before that we don't like relationships. We want to avoid relationships here. So I'm not going to do that. I'll take that off. I will double click on book. When I do this now, I'm in a different mode in Tableau. Tableau is getting ready now to join the tables rather than construct a relationship. I'm now going to drag ratings over to the right. Here we have it now. So now we have book and ratings, and you can join them nicely. Okay. In fact, we've got by default a inner join. Now, you might be wondering, we didn't specify the key used to join the tables together. Well, the good thing is Tableau figured that out on its own. Tableau made a decision that we maybe want an inner join out here. So if I click on this, overlapping area of the Venn diagram, you can see we can choose different options here: inner, left, right, and out, full outer join. Also, we could join using a different field if there was another common field. Usually Tableau look at the variable names and figure out from that if they're similar or can be used to join the 2 tables or not. Okay, so now what we have is we have a table with 49,000 rows. Every table, every row has a book ID and ratings. I'm sorry, rating. You'll see book ID being repeated, by the way. Okay, so that's good to point out here. So book ID is being repeated here because one book ID is from the book ID, the book table, and I'll kind of point that out here. And the other book ID is from the ratings table. See that also. Okay, so you can kind of get this nice table from joining 2 tables together. Okay, and now you can do fun stuff like find out what is the title of the book with the most ratings, for instance. So let's just do some fun stuff here. So let's go and take a look at our table here. And we haven't done much of this, but we haven't talked enough about constructing tables. But let's take a look at this in an exploratory way here. So book, say joins, being joins, right? Book data, let's say 1, okay? And so we're doing one simple thing out here. I'm going to, first things first, I'm going to kind of organize this so that it's by, not by the source, but rather by folder. So we're ignoring the source of the data right now. And let's take a look at here. Let's see what is it trying to do here is to look at the title of the book with the most ratings. So I'll drag title over to rows, show up all the titles for us. Now we can get the one with the most ratings. I'll drag. I want to get a count of ratings out to the columns. I want a count of all the rows to show up on columns right now. Okay, so let's try dragging book count. What does it contain? Let's just take a look. Okay, I'll just, just give this a go, see what happens. Okay, so this is showing me in the bottom that there are 49,000, values of count book, which is a good thing. It's telling me that this is all the data, right? So I'm going to go and sort this now conveniently enough and see which is the number 1 book here. or the book with the most ratings. Alternatively, you might want to see, well, which book has the best rating. So let's find the rating variable and drag that over here. We'll get a second table on the right. That's okay. And we'll kind of specify here the average rating. And let me sort that data by average rating now. You'll see, even in terms of average rating as well, on both kind of variables, the number one book is this one I can't pronounce. Okay. So this one has the best rating as well. You can see the rating is like really high up there at, what is it, 4.7 or something. Okay. So we had some fun there. I hope you saw that it was fun as well. We can now try and do one more thing out here. What we can do here is we'll try making another kind of join. This time we'll make a table. We'll make a join between book and info. This is a little challenging because if you're going back here a little bit, you'll see that there's a book ID here in the book table, but the book ID table doesn't, sorry, the info table doesn't have a book ID table in it, or sorry, field in it. It has a book ID 1 and a book ID 2. As it turns out, book ID is basically a combination of book ID 1 and book ID 2. So we can create a variable in info to join the two tables. That's what we're going to do next. So going back to Tableau, I'll go back over to our data source window. And I'm not going to break up this join. I'll leave that intact. I'll create another join this time. So we're going to find the info table. Like info tables here. I'll drag that into the little window here. The orange window is getting marked up. And just drop it right on the right side of rating. See what happens then. Tableau's like, okay, I don't know what you want to do. There's an exclamation mark up there because it's telling us that it doesn't know how to join the two tables because there is no common field or common variable. So we'll explain to it what it is. So from book, we want to use book ID. And from info, we want to use a combination. We want to use a combination of book ID 1 and book ID 2. So we're going to create a join calculation here. It's going to look like this. So let me do that again. It was kind of fast. So if I click on the down arrow by info, it opens a window for create join calculation if you select that option. Here we're just going to say book ID 1 plus book ID 2, and that's it. And hit OK. There you go. You'll notice if you look in the bottom, we now have, let me just go to the bottom here. So you look at book ID, it's got a number 8222 for first row. If you scroll over, look to the right, there are, let me find out. You'll see here, book ID is 8222, same the rating table as well. And in the info table, it's a combination of book ID 1 and book ID 2. That's what we did. Okay. Lastly, you can see right now we have 49,000 rows of data. Now, what if I said to do a left join? Let's do a left join here for book. So let me just do a left join here for book. Okay. So I don't want to do it up here because I don't think it's going to matter, right? I'm assuming every book that exists, we have information on that. Which we can, of course, test in a little bit. For now, let's just try and see what happens if we were to select, left join here, which means we want to get a list of all the books, whether or not they have ratings. It is conceivable that there's a new book out there with no ratings. So observe now what happens to number 49782 when I select left out of join. The number's changed slightly. It went to 49784, meaning there are two books that don't have a rating. Now, is it possible there's a rating for a book that we don't have? It's possible, right? There are books that go out of print. So let me click on the right outer join now. And the number is 49782. Now I'm going to go back to inner join again. Number's the same, which means every book that we have a rating for, we have the corresponding book in our kind of book table. Fair enough. Okay, so let's try this now for info. This would be interesting if there's a mismatch out here. Specifically, is it possible there's a book we have no info on? Troubling if that's the case, right? So I'm going to click on the left outer join here, and that's not the case. Is it possible there's info in a book we don't have the book for? Indeed, there are two books we have info on, but the book doesn't exist with us. We don't have the book. That's interesting. Okay, I'll leave this as it is and move on now. Okay, so we have now here examined, a whole bunch of different kinds of joins you could do: inner join, left outer, right outer, and a full outer join using this Bookshop data set. Okay. Moving along, a bit more about joins. So if your tables are in different folders, what's going to happen is you'll be constructing a cross-database join. Okay. Let me try and simulate this with an example. What I'm going to do is on my computer, I'm going to move the files. I'm going to take two files. I'm going to and put them in different tabs. Or rather, you can do this in your own as well. You could take your data and put them in different files. If you do that, what's going to happen is, let's try and do this actually. So I'll move ratings over to. So in my computer, I'm kind of reorganizing my files, move some files around. Bear with me here while I get this done. Okay. Okay, so I have now on my computer done something, a couple of things going on here. So two different things going on. I'm going to open another Tableau session so I don't mess up the current session I have to open. In this new session, what I'm going to do is I'm going to get the book database loaded up in. So here we are in this new Tableau window, Tableau session. I'm going to open up the Bookshop dataset first that you've seen before. And now I'm going to open up another data set. This is going to be a ratings data set. Okay, that didn't work out very well. Okay, go back here. Okay, so I'm going to add a connection on here. And if you've done this before, you know not to be doing this, right? So I'll go and say here text file and say ratings.csv. And notice what Tableau is doing now. It's marking this, it's saying that I can make a connection for you. Sure, I can do that. But it's going to be across different platforms or folders. So let's see how we would make this work. Here's the book database. Again, I'm going to get the book sheet from here. Just double click as before. I'm going to drag book over. And here we are. So you notice here what I've done is I actually moved ratings to a different folder. And it's also different for the CSV format as well. So a lot of things going on. And I have the same book file table as before, same ratings table as before. We're getting the same kind of table, but notice the coloring. The fact that there's orange and blue indicates that Tableau is seeing this as being a cross-database join, which in a nutshell means they're being treated as being in different databases, which also means that you'll have much lower efficiency, performance issues, and so on. So it's always better to have all your data in one folder, work off the same database. And bottom line, don't do cross-database joins. They're just inefficient. Okay, so don't do that. Okay, so moving along, last thing I'll kind of touch upon here is Yeah, so one thing, variables, so generally you want to make sure the variables used for join of the same data type, and so on. Okay, the last topic, I guess, is about data blending. So Tableau has this unique, ability to deal with data at different levels of grain or granularity. You can have a data that's at a, the city level, and you can combine that with state level data. So the grain is clearly different for this data, for these two different data sets, but Tableau allow that through a process called blending. So in certain situations, blending is a nice option available. There are, of course, a number of limitations in where and when you can use blending. For the most part, I'd say avoid data blends completely. So it just creates more problems than solutions. So I'd rather not even be doing blends, but it's an option available if the grain of the data sets you're going to combine are different. One is rolled up, one is not. Let's say one is daily data, the other is monthly data. That's when you use a data blend. All right, so to wrap it up then, we've looked at a number of different topics, right? From connecting data to parsing, exploring, filtering, sorting, cleaning, tidying, unioning, joining, and also we took a look at how you can blend your data as well. Okay. Thank you for joining me for this session.